a meeting, don't be shy and ask while I will be teaching. And also, sorry in advance, but I will be speaking quickly. Like, so this is why also just let me know if in some places we need to stop. And I hope you are able to see the screen with the title slide. You should be. You too, yeah? They
Yeah,
probably
it's okay.
as well.
Yeah, we do see it.
Okay. So just like for the introduction, like as Ilona Skachkauskena mentioned, like she and Antanas Tchenys is responsible for the course, but you will have separate lectures by different teachers. So today I will be teaching you more or less about data. I'll call it like a simplification, like it's called data, because we will be talking about different aspects of it, how to gather it, how to pre-analyze, let's call it like this, was a quantitative, qualitative research, and so on. So the topic like which is described like quantitative and qualitative research, understanding and meaning of data, data journaling, preparation, preprocessing, visualization, measurement, validity, and reliability. So this is why like the topic is kind of a broad. So this is why I will be talking quickly. But as I mentioned, if you will have questions, just ask. So the plan of the lecture is according, like because the topic was composed of those 4 sections, we will be talking about them as well, like what are the differences of qualitative, quantitative, probably you know it from the master thesis, making sense of data, logging, measuring, and so on. And also I should be talking about what should be the outcomes, because like, why are you studying? So after this lecture, you should be able to understand the data role and impact to research methodology, because like, it's not just like data as such. In most of the cases, if you are using AI related and the research related experiments, probably the data will be the core element. Like based on the data, you will be analyzing the results, estimating how accurate your method is, and so on. Also, you should be able to apply informative data mining and visualization. So it's difficult to estimate, like, are you able to apply? Because now you just will get some knowledge, like I will try to share some experience. And also in the exam, you will have just test, but the test usually is like some kind of a, like not just a question, what is this, but trying to provide you some kind of a situation and asking to evaluate and so on. And also the third element, like the outcome expected one, is like estimate research data validity and reliability. So basically to estimate, is the data suitable for my experiment, for the results and so on. Yeah. Before going into the data, what's the quantitative, qualitative, and so on, I like this approach, like how you should be thinking. And it's relevant to both projects as well as your research and so on, because all the projects which you do, all the research, I don't know, implementation and different kind of projects, always you should be thinking about what's the impact. Like, why are you doing? What kind of a change in the society, in the industry, and so on, you are trying to achieve? And automatically, you should be structuring it. So, like, yeah, final result is I want, I don't know, the word to be safer for children and something like this. And then you should be dividing into some steps. So, first of all, what input you have. So input in most of the cases will be the data when you are collecting and trying to do something with it, but not necessary. It could be some actions and so on and so on. And basically from the input, what you have, you are constructed it into activities, what you can do. With the activities all the time, you will be getting some output, what kind of results you achieved. So also like data is not just input, output also could be a data based on which you are evaluating. And also, like based on the results, you could estimate what kind of outcomes I'm trying to achieve. And why I'm showing this image, just to say, like in each of those steps, there will be different assumptions and influences. The environment will influence your project or research. Your assumptions, like you believe it should be like this and you are not discussing something else or something like this, will affect the situation and so on and so on. So this is why when you do scientific research, it would be good if you would try to analyze all the time. What are the assumptions? What are the influences? And would try to estimate like what is the impact of those in each of those steps. And also one more important thing, like if the final outcome is like what kind of a change and impact you are trying to achieve. So usually the outcomes which you can produce is not the same as impact. What I mean, like I kind of liked one example which was explaining what's the difference between impact and outcomes. So for example, if I have a problem, because most of you are solving the problem, so the problem could be I have a thirsty horse. So the horse is thirsty, he cannot work and so on and so on. So the impact which I'm trying to achieve, the horse will be drinking a fresh water and will be ready to work further. But I, as a project manager or as a project as a whole, what I could do only the outcomes. So the outcome would be I'm giving water to the horse, but I cannot force the horse drink it. So this is why I'm adding this one as well. Like all the time when you will be thinking about the impact which you try to achieve, think it in multi-perspective. So it's important not just to give the water to the horse. It's important, for example, motivate the horse to drink, maybe to test the quality of the water to make sure it will be suitable and so on and so on. So this is why it shows like a tree, like I trying to achieve just one impact, but I have multiple outcomes, multiple outputs for each of those and so on and so on. So this is why PhD thesis isn't so easy. Like you will have a huge amount of tasks to do just to achieve the final result. Yeah, so how we go from the input to the outcome, because the impact is out of our control. Usually we get data to define the problem, to test what's the situation. Then we analyze data. And also when we get the results, it's also data which we should be interpreting. Yeah, Martinas wants to say something. At least he's raising a hand.
Yeah. I wanted to ask, what if like we don't know what we want? Like we have inputs and we just like trying to research what outcomes will be. Like we don't know. In your example with the horse, we like know what we want to achieve. Like we want to horse drink water, but in some cases we don't know what the outcomes or will be. So
Yeah,
how
like
in
you will have a
yeah.
lecture with Antanas Chanis, and he will be talking about the research philosophy, something like this. So what you are saying, I understand. Sometimes it could be research like this. I have some technology and I want just to, for example, investigate where it's suitable, where it's not suitable, and where it could be applied. But it's just a question of perspective. Like, for example, in your case, maybe the problem is we do not know the limitations of the technology. And the impact will be like we will have all possible information about the technology and its limitations and, I don't know, advantages, applications. So it's just how you will convert the situation. Like you always, like if you will present just, okay, there is a new technology, I want to play with it, I want to test it, the researchers will be very skeptic to what you are telling, because it will be like, come on, you should be solving some kind of a problem. It's not like a playground. But if you will say like, yeah, my problem is I do not know how it could be applied, and the impact which I'm trying to achieve is a better understanding and better application of the technology because we have additional knowledge. And also, like probably Antanas will be talking, like the research usually is what's the outcome result which you are achieving. You have additional knowledge, like you are extending the circle of knowledge. So in your case, the same. So just formulate it a little bit different and you will see you have the impact, you have the outcomes.
Okay, thank
Yeah.
you.
So coming back to this one, so just like illustration, in each of those steps, there will be some kind of a data, like input, output, results, analysis, and so on. And also what's important to know, what's the difference between data and information? Like data is, I like an example, like 14. It's data, it's a number. What does it mean? You just can guess. So if I will add metadata, so metadata is data about data. So for example, I will tell it's a temperature. So, okay, 14 is the temperature. Then I'm more aware, like it's not so warm, it's a little bit cold, but also like how much metadata we should be adding. Usually it's also like infinitive. Is it summer or is it winter? In winter, it's warm in Lithuania. In summer, it's cold, freezing. And also like in which country, on what daytime, is it outside, inside, and different things. So like all the time, when you're analyzing data, try to collect data about the data as well, because only gathering all the metadata, you will be able to extract the information, to show the knowledge rather than just numbers. Yeah, now if we would talk about how to identify the data, so if we know the aim, problem, situation to analyze, automatically we could understand the effect. Also, we should be analyzing what kind of a structure we have, like based on the structure, what are the possible factors and so on. So basically, what I'm writing here should be summarized with such a thing like fishbone, or it's called differently like Ishikawa diagram. So it's not necessary for all of you to have it, just it's like a recommendation when you have your problem. So usually problem will be the head of the fish. So something here, for example, in the basketball, like missing free throws. And then we are trying to analyze like, okay, what could be the reasons? What are the factors, causes? So we could define it into, in this example, there are 5 big categories. Now I'm not able to see, for example, there is something related to people, about material of the ball, method, how it's thrown, and so on and so on. So, and yes, like if the ball will be not standard shape, or I don't know, if the environment will be different, if the player is bad on free throws and so on. So I should be taking into all of those factors. And even those, because in most of the cases, it will be difficult to estimate, like how I will evaluate the player, the shooter. There is no one specific data which I could express. It's if it's just name and surname, it says nothing. I should be going further to analyze more data. So then what we do, we just go deeper. Like, okay, what kind of a properties defines the people, the shooter? Like concentration, motivation, then the training. Training could be divided into those and so on and so on. So when you will do such a kind of a diagram, and I was imagining like, okay, I'm a freak of structuring and I like these diagrams, but in most of the cases, my diagram just one A4 format sheet. Like it's not very big, but like it summarizes what I know about the area, about the problem. And in one PhD thesis defense, one student came with a supervisor and he took A0 sheet with full of also such a small text. But what the diagram allowed them to discuss, like they were understanding the area, they were understanding what kind of a data specifies each of those and how they could be going further to understand how to extract it, what should be the constant variables which should be manipulated and so on. So for example, if we have also just a simple experiment, what we could do, we could estimate what are the primary causes, like what are the main factors which influences the accuracy of the throwing, something like this. And also, like it says, like mathematical correlation, like in this experiment, they were estimating what were measured, like how the, for example, ear pressure affect and the rim play tightness affected the missing throws and so on. So it's not necessary to do something like this, but also you, when you will have the full fishbone diagram, you could identify like, okay, I will do my experiment and I will guarantee the machine, the hoop and the backboard always will be the same. Because if I will change it in the middle of my experiments, it could change the results as well. So you could estimate what will remain always the same, and you could estimate what I will be changing. So for example, Martina's was mentioning, maybe it's like how to apply one technology or another. So maybe the key factor which I'm changing will be the different methods, the different technology. I will use it in different environments, but some conditions will be the same just to make sure the results are comparable. Because if I will measure the same temperature in university during the summertime in Lithuania, and I will measure the temperature outside in, I don't know, Australia during summer or nighttime, so the numbers probably will be the same, but the conditions are completely the same. So does it mean it's the same temperature in Lithuania and in Australia? No. So this is why you should do experiments in as possible, as controlled environment as possible, and taking into account what should be changing. Now, how you should be collecting the data. First of all, what kind of data you need? You are from different fields, and each field has a different specifics on data, what you are operating. For example, engineering studies usually will be oriented on numbers because like quantitative analysis is easier. Like I'm just comparing numbers, I'm getting the results and so on. Social science studies usually are collecting stories. And based on the stories, they are doing the qualitative analysis and so on. So this is why you should be trying to understand what are your data, what you will be collecting and what you will be operating. Also, what are the influencing factors? So as I mentioned, if I'm measuring the temperature, so what I should be taking into account? The environment, the measurement device, I don't know, some conditions, how many times I'm measuring and so on and so on. Where the data resides, so automatically also like where I will get the data, because if I'm collecting data from people, I will need to convince them to provide the data. How to convince them? By paying? Probably no. They should be willing and they should act as natural as possible. So there are some research when they get the survey participants are getting some salaries, but like you should be taking into account the where the data is and how you will be extracting it. Just questioning, filling the data, measuring, parsing or mining from some sources and so on. Then how many resources you have. So resources could be kind of a wide term. So how much time you have, because usually you don't have 5 years to collect data. You have probably just about 1 year maximum to collect the data. All the rest should be about the analysis and experimenting with the data. And also, in some cases, it could be not just about time, it could be about maybe some infrastructure is needed. Like maybe the data set which is required is a huge one, and I will need at least 2 years to gather everything from the internet or something like this. Then also like related like data and its retrieval complexity, how difficult it's to gather the data, frequency of data collection. So also in some cases, there is no such a thing like data drifting. The situation is more or less the same. But in some situations, if you will do a survey on September, and then if you will do the survey on, I don't know, December, the results which you will get could be also different because the student during the first semester were very motivated. Meanwhile, during the December, they're just waiting for Christmas and something like this. So you should be thinking about what the period is, how frequent it should be, like it should be repetitive to estimate the timing influence or no, and so on. And intended forms of data analysis. So also like how finally your data should be structured to make sure you will be able to analyze it. So as I mentioned, if it's stories, so probably also it would be nice to have a clear document with all the stories rather than, I don't know, some images which are not readable or something like this. If it's numbers or just structured data, what kind of form it should be. And the main rules for collecting data. So it would be nice to use multiple data collection methods. So if I'm gathering, I don't know, data about student satisfaction with the studies, so I could do a survey. But maybe maybe the survey was issued on the day when students had a very complicated lecture. So probably the full student satisfaction will be kind of a low. So it depends. But if I will collect data from student survey, maybe I will collect data not in anonymous survey, but talking with them in some kind of an event. Maybe I will collect the data based on, I don't know, students' employment rates and so on. So I will have multiple data sources, and I will have, like, as a researcher, I will have more data to analyze and present it in different perspectives. But also from the researcher perspective, potentially I will have more accurate data. And at the same time, there is a pitfall. What kind of issue could raise if I have multiple data sources?
How you would analyze this data by having one template, you will have like different methods to analyze, and you will not be able to compare it easily.
Yeah, like it will require potentially different methods and additional workload. But the biggest issue is, what if I applied, I don't know, 4 methods, and I got 2 stating it's very good and 2 stating it's very bad? So they are contradicting each other, and then I'm not sure, like, so is it good or bad? So, and always, like, this week was kind of intense with master students, and I was explaining, like, why research is a good thing, like, and interesting. There is no good, bad, right, correct, incorrect. There is just your creativity, how you will turn all the situation, what you will do, and so on. So if you got those contradicting results, so it's additional section where you can discuss why it's like this, why it's like that, which one is more important. So it will be a bigger chance for you to present more valuable results by analyzing, rather than I applied 4 methods, all of them showed like it's 99.9999999. And so it says like there was no reasons to analyze, because it's clear all measurements show it should be like this. Yeah, at the same time, you should be using available data if it's possible, because if you will be gathering the data, it will take time, and it has a different side. For example, if you are using some machine learning method, some researchers already created similar models. You collected your own data set and trained and collect and used different machine learning method, and now you are comparing those results. Your result is another author's result. Is it comparable? No, because the other author used different data set. So yeah, you could say we got the same result, but based on like the situations are not the same. So you cannot compare it so like simply. You should be either using his or her data set with your model and looking how with the same data we get, what are the results. And then you could use your own, like just to illustrate, like, and with mine, which is more like real world data, or I don't know, bigger amount of data is added, something like this, you could define like, yeah, like it also performs well. So and also like why it's important, like if you are using the existing, so probably they already justified it by defining what kind of a measurements they used, why it's correct, how the data was collected, and so on and so on. If not, when you are creating the data set, when you are collecting the data, you should be mentioning all those things, like how you measured, when you measured, what conditions, what are the distribution of the data, because it will allow to estimate like how much you have the missing data and so on. Because in research, when you are writing scientific paper, we will be coming to it in another lecture by me. So you need to write everything to make sure it's repeatable. So the same with the data set. If you are presenting something, you need to explain how it was created, how it was gathered, just to make sure you justify and everyone believes like, yeah, it's correct. It's not just random numbers added in the data set and specifically selected for your case to have high results. So it's good. Yeah, so if you must collect original data set, so you should be sensitive to burden on others. Pretest, pretest, pretest. So basically it means like when you are collecting data, do not try to collect all the data instantly. For example, if the data is coming from survey, so usually there are some iterations, multiple iterations. You are creating the initial survey, you are giving to your colleague, like, is it correct? Like, fill in. Is there any issues? Then you probably are giving to some persons from this field, like, is it really clear what should be added and so on? Like, and also like pretest could be not just for data gathering, it could be for data collection as well, because there are some situations when you create, for example, the same survey, you are collecting the data, and when you need to use it for the data analysis, then you suddenly understood like, oh, I missed to ask what's the gender or what's the age, and I need a perspective based on the gender or age, something like this. So also when you are collecting some initial data, you could try even do the initial data analysis to see, is it really enough? Like, will I be able to get something? And then continue with the fulls if you have time. If you don't, so it's another question. So also establish procedures. So it's very critical if you are measuring something, because some devices, some methods are kind of sensitive. And if you won't be following the same procedure, you will get completely different results. Why in medicine, all of them are wearing glasses, gloves, and so on, just to make sure nothing affects, and they are logging all the actions, just like to make sure they will be able to repeat and provide the same conditions. Yeah, like maintain accurate records of defining and coding. Like it shouldn't be like one day you are noting in one notation, like coding the results, another day in another, and then it's difficult to understand what's happening. And also, like as I mentioned, with the pre-testing, like you could do some initial tests just to understand, like, is the data correct? Like, should I proceed correcting it? Will it be enough? Or and things like this. So talking about structural approach, so yeah, do use the same methods, the same devices as much as possible, because yeah, in some situations it will be complicated. Yes, and if you are using multi-case cluster evaluations, things like this, so it's especially important, for example, if the data is collected in Lithuania and, I don't know, in Spain. So if one team will be collecting the data in one way, another in another way, so you probably will get results, but you won't be sure, is it related to the real causes or just how you collected the data? Was it just questioning in person, or was it anonymous survey? Because sometimes, for example, a human cannot tell you frankly, they are willing to provide it anonymously and so on. Yeah, and estimate what are the alternative cases. Maybe it's not necessary to collect the data by yourself. You can use the existing ones and so on. Yeah, like it could be like you could add additional questions. And one more thing, talking about the data testing, pre-testing. So as I mentioned, with the pre-testing, what you can do, you can estimate, is the data suitable for my purpose? Like, can I analyze, do I have all the features which are necessary for me to do the analysis? But at the same time, my recommendation would be, even if you have a very clear purpose, and when you are collecting data, just analyze, maybe it won't cost much to get additional data. So for example, what to think? Okay, my head is empty. But the idea was, maybe in the same survey, I could ask not just about study quality in the university, maybe I could ask just several additional questions about the enrollment process. So for the student, it will be who is answering, it will be just a minor addition, but at the same time, you will have additional data as an additional branch to your research, just to express, like, not just how the study quality is estimated by the students, but also you will be able to estimate, like, how they evaluate the enrollment process, and maybe there is a correlation between the enrollment and the study quality or something like this. So this is why, like, try also to think, maybe you could extend the data, and it could be useful for you with no huge resource investment. Also, if you have as large sample number as possible, it's a good thing. Usually the issue is we have a limited, and we need to justify why it's like this, why it wasn't possible to gather more data. Know what should be measured. Also, in most of the cases, if you will try quantitative methods, you will need one way or another to convert the data into numbers, to code them, to do some statistical analysis. If it will be just text, yes, you could do some case analysis just by analyzing, but in one way or another, numbers in any case will help you, at least expressing like how many persons participated, what's, I don't know, the sentiment of it or something like this. Yeah, and also like try to, if it's possible, like, and if it's not out of topic for your research, like do some comparison across different cases or interventions just to estimate like, is those conditions which you are changing, are they affecting the results or not? Because one of the research areas is not to estimate some, I don't know how to call it, like not even a correlation, but dependency between some factors, but it's more to estimate the stability. For example, okay, now it's nonsense, but if I'm measuring the temperature, is it really accurate on different pressure conditions or on different weather conditions and so on? So the more different conditions you will try the measurements, the more like trusted results you will get. Talking about semi-structured approach, so yes, not always you can very clearly structure how to collect the data, how to process it, and so on. So you could follow some kind of a systematic approach and on the go add some additional elements. So this approach is more dependent on your experience. So usually, probably your supervisor will have some kind of a feeling, this should work, like you should do like this. But it comes with an experience, so this is why some kind of a adjustments could be done on the go, because in advance from his or her experience, he had some kind of understanding what could be done. With no experience, it's difficult to do it in a more flexible way, but like, yeah, like you could do some variations, just always try at least to log them to make sure you will have the data as evidence, like what was changed and how it affected the final result. Yeah, like conducting exploratory work also, it's related to the fact like you could try to see like, is it affecting initially and then do a more deep analysis, or even the exploratory phase could be done by doing research analysis. Who did something similar? Because one professor used to tell to our group, like, if you are doing something completely new, no one did it, you will create some huge novelty. There are two possible paths. One is you should be getting a Nobel Prize. That is a really, really small probability. Another is you should be getting to a room with no windows, no door handles. So it means like probably you are crazy. Probably you do not see the problem. Basically, there is a third option. Maybe you just do not know it exists. So this is why doing the research analysis, trying to understand what exists, how other researchers analyze the data is kind of important, because then you could justify what exists. You could highlight what's your novelty in comparison to them, and also collect the best practices, how they collected the data. Maybe even if the data is not available, maybe you can use the same method to collect your own data, and then say like, okay, even if it's not the same data, it's gathered with the same procedure, so it means it could be comparable. Yeah, so with social science, you could do something like to seek the understanding, not some kind of a numeric comparison. So you will need some narratives or stories. You will go deeper into the analysis, and there are some like test cases when when you are not sure what you will be asking during the survey, like not survey even, like the experiment. You are starting with some initial structure, and then during the talk, for example, with the expert or with some kind of a person whom you are talking with, you could be more creative and dive deeper into those questions which are important, and so on and so on. Yeah, with those. So what are the characteristics of good measures? Is the measure relevant? So is it really important for my research? If I'm estimating student satisfaction in studies and I'm measuring the temperature in the room, maybe it's not directly, but affects how the students feel and so on. So it could be added, but like probably it won't be the primary course. Is a measure credible? Like, can I trust? Like, is it trusted more or less? Then is it valid and is it reliable? So if I remember correctly about each, yeah, like about each of those, I have slides. So with the relevance, so this did the measurement capture the matter. So the essence was I mentioned, like with the temperature, like, yeah, it's probably related, but I have no evidence. So it could be collected, but not as a primary source of data. And then just to analyze, is there any correlation? Is there any dependencies? So usually in the first place, you should be trying to gather those most relevant measures, most relevant data. So this is why having the fishbone diagram also could be a source for you. But when you are building it, also do not be scared to use some research analysis just to estimate, like, okay, they were measuring it using this metric or this metric and something like this. Yeah, so like in this case, if I'm predicting students' dropouts, we will be measuring the final score of the course and student activity in the midterm score. So those are probably most relevant to estimate, but I do not know the final list. Like potentially there are different reasons, but if I will try to measure, I don't know, what shoe size each student is wearing. So no, there is a really small chance based on the shoe size. I will estimate will the student finish the studies or not. With the credibility, so yeah, like is it trusted? Can I believe? So usually with those, it depends on the situation. Like, are you using suitable measurement devices, or is the conditions clearly estimated? So for example, if I'm using to estimate the car pollution level, is it credible to look at fuel type? Is it gasoline? Is it electricity? Or is it diesel? If I will do this one, can I say like, yeah, if it's diesel, it's very polluting. If it's petrol, it's good. Probably, because it's one of the main criteria. But usually there are multiple factors, like different engines, even with petrol, are producing different level of pollutants and so on. So sometimes having just few parameters might be not enough. So this is why you should be going deeper, getting as much different measurements as possible. And then during the analysis, you will be able to filter out some of those which illustrate like, no, it's not related and so on. Sorry. Yeah, then about internal validity. So basically, you could do some smaller experiments, as I mentioned, just to estimate, is it suitable or no? So, for example, in this case, it says like, our waiting list a valid measurement for demand? For example, if, what we have, okay, there was one article and they were saying like the company, it's not exactly this example, but the company didn't detected any cybersecurity attacks during this year. And it means the measurement, like the protection mechanisms which they are using in the company are very suitable. So would you trust this measure? I wouldn't, yeah, because there is a chance they just wasn't able to detect it. And it means it's really bad situations. They are not even able to detect it. So this is why with the validity of the data, like you also should be trusted, like looking for trusted data, like, and convince why it's really like this. So if I'm saying like I was analyzing the cybersecurity attacks and I didn't detected any during the year, so maybe I should add additional information by estimating like how good my intrusion detection systems are or something like this. Yeah, and reliability, because at least in Lithuanian, all those terms sound kind of a similar one with another. So this one is more related to precision and stability with the data. So for example, if we will be Counting, okay, in this case, what I usually do to estimate this one, I'm looking what is the standard deviation, because we will be talking about it, but it just illustrates how big variation exists in my data. So if the variation is small based on the like possible interval, so it says like, yeah, when I'm measuring, it's more or less correct. But if I will have an average of, okay, it says like birth weight of newborn infants. So on average, we probably will have something like 3.5 kilograms or something like this. But there are some cases when we have newborns with 1 kilogram only and so on. So in those situations, when you have data, either you should be having close to it some statistical metrics which define how reliable the data is, or you should be also thinking about how it was measured, how it was gathered, just to understand like the result. And also like if you will be measuring the time with just watch, like I'm just clicking to start and I'm clicking to stop, is it suitable method to estimate the time? Yeah, because usually all the questions are, it depends. If the time interval is just, I don't know, milliseconds, no, I cannot achieve milliseconds. My reaction is too slow. If I'm counting hours, what's the problem? Like I will take maximum half of a second to click it, so then it's reliable. So this is why like there is no correct answer. In most of the cases, it will depend on some situation. Yeah, and talking about quantitative and qualitative approach, those, as I mentioned, probably you know. So quantitative usually is when we have numbers. And in some cases, even when we do not have numbers, we have categories, for example, cats and dogs. We are converting it to numbers because especially machine learning, it uses just numbers. Even images are just vectors or matrices of numbers. So by converting, we will get the number and it will be easier for us to do some kind of a calculations analysis with numbers rather than with categories or one qualitative data. So for example, with those like age, cost, and so on, it's kind of easy. Uh, with those categories, sometimes it's tricky how to convert because also I should be thinking how to aggregate the data and so on. And also, like we have an expression, there is a white lie, like when I'm lying because of good reasons, black lie, when I'm lying because of bad reasons, like I want to harm or something like this. And the worst category is statistics. So with quantitative analysis, yeah, you could get numbers. You could use those numbers to justify, for example, if I was, I don't know, doing the same survey of study quality in 10 grade scale, and half of the students told it's 10 and half of the students told it's 2. On average is 6. But it shows like there is some kind of a problem. Some students are evaluating it good, some students are evaluating bad. So probably inside of the organization, there is some place which is terrible because half of them are saying 2. But on average, it's average. So this is why we are seeing like statistics could be used for not suitable like justification, and it's important to go deeper. If I would provide some variations by explaining it ranges from 2 to 10 and the standard deviation in this case will be big, so then it would explain better. Yeah, and with the qualitative approach, so as I mentioned, it's more common to social science, arts, and so on. Not always you can measure it in numbers. When you need to go deeper into what are the reasons, what's behind it, and so on. So then you are going deeper. You are asking for opinion. You are trying to estimate the conditions and so on. So not everything can be converted to numbers. Those are more common to some fields. So if in engineering you will see like I did I don't know, some interview and I'm now presenting why the users like this approach better than this one, probably the defense committee won't like it. So yeah, what data to use where? So there are like also just the recommendations, you can ignore it. If you want to conduct a statistical analysis, so probably quantitative, unless you will do qualitative and express it in numbers, but it might be too difficult to implement it. If you want to be precise, like to explain like in numbers, what are the differences? Because if I will explain like this group evaluated is as a good and this one as an average, for me it sounds like I need some numbers. What's good? What's average? What's the difference, and so on. Know what you want to measure. So yeah, like is it opinion? Is in what scale, and so on. What to and also like you probably will need to cover a huge like big amount of measurements or data points, because only then you could use a statistics. If I just took, I don't know, 2 experiments, I got 2 results, you cannot do statistics with 2. You need more. So in this case, you could use some more qualitative approach. And also, like if you want to go deeper into the analysis, so deeper could be also quantitative, but in this case, it means like what are the reasons, and also like if you are not sure how to measure, what kind of measurements exist. And if you do not want numbers, just you want more qualitative oriented result rather than quantitative. Yeah, now talking about obtrusive and unobtrusive methods. Yeah, so with obtrusive, it should be when you are collecting the data directly. So it's more like when we are talking about the qualitative, like interview, survey, focus group, and so on. With another one, when you are getting it not directly. For example, if you want to estimate what is the company position regarding Gen AI usage. So if I cannot do the interview, I could use unobtrusive methods. Like I could analyze the documents and what's written in the document. So I'm not directly asking, like using like secondary data sources, but still I could get the data from here. For example, also if you want to, I don't know, estimate some kind of what coverage of forests is in different countries, in different regions. I could go and measure it by myself. I could go into some existing, maybe I could use Google Earth and so on and so on. So also you could use the secondary data. It's not a problem, but just in most of the cases, you will need to justify why it's correct. Maybe Google Earth is having data from, I don't know, 3 years ago, and now there is no forest anymore, but it's still showing it like this. And there is another thing like triangularity. So with triangularity, the main idea is it would be nice to use different methods, different data sources, or different evaluators to check, is it still the same result? So it's like if I'm asking some kind of a question, I don't know, like is the board green or blue? So if I'm asking just one person, like I do not know, is it really correct? If I will ask multiple persons, so it will be like triangularity of sources. So different persons express their opinion. So like I'm sure like, okay, the first one wasn't daltonic. He knows what the color is, and because all of them were saying the same. Sometimes it happens like, okay, if you had multiple sources, and as we discussed, like one of them is saying different things, so also you could like estimate the quality of those, or just to base on the majority opinion, something like this. Triangularity of methods, also you are using different, for example, measurement methods if it's possible, and by using different methods, if you got the same result, so it probably means like, yeah, probably it's really correct. It's not some kind of a issue with the calculation and so on. And with the evaluators, so how we evaluate it as well could be, we could use multiple of those to see. So it just adds additional trust to your experiment, to your research, because you tried different approaches, different sources, and so on. Now, how to collect the data. And also just one more thing. Usually I'm just talking without break. If you will need some break, just let me know, because I'm not checking the time. I forget about it. So with the
Okay.
data, yeah.
Thank you for informing.
Yeah, so talking about the data collection, so different methods exist. So probably I won't go deep into each of those. They will be in slides, but I will share the slides after the lecture. You will find some short description about each of them. And there is no clear definition which method is suitable for you. Like you are looking into the context, into the metadata. Do I really have trusted experts? Like I have no doubt they are professionals, which means I do not want to test them or to have some discussion of the experts and so on. Or is it like it's just like I'm asking the opinion and so on? So there is a list like participatory methods, records, and secondary data, what we were talking like it could be used secondary data. Observation, when I'm not affecting anything, I'm just looking how the people behave or mouses behave and try to do. You can do surveys, focus groups, expert judgment. Delphi method is also like expert judgment, just they are discussing doing experiments. And also, if I would ask like which of those methods are more appropriate to social science and which are more appropriate to engineering. In most of the cases, probably like most of those will be social science, and engineers probably will be doing just experiments. They will be modeling, measuring in different conditions. Also, like probably they will use data records for the analysis. It doesn't mean it should be only like this. It will depend on your problem and so on. And also probably the best option is, okay, I don't have it, or at least later. The best option probably would be to combine different approaches. For example, I could do experiments for the numeric data comparison. For example, I don't know what to say. What could be the example? Okay, let's do the same student dropout. I collected the statistics, I created the model, so now I can predict. I'm using the data from new student, like from the latest semester to estimate how accurate it is. But in the end, when I created the model, I could ask, for example, for the teacher, for the administrator, how you feel with this prediction. Like, is it realistic? Is it explainable? Did you understood which student are under threat or something like this? So it could be multiple stages based on what you exactly want to achieve, what's the impact. So as I mentioned, yeah, there will be those methods shortly listed. Observation, helpful, and so on. Okay, just I will go quickly because I see we do not have much time. Data log, yeah. And with this one, like, because the ending is like when you execute all those experiments, I know it's very boring, but you should be collecting all the data. And what I mean with all the data, also coming back to the machine learning, for example, approach, usually students are collecting maximum the model accuracy. And after, I don't know, 20 experiments, they say, like, okay, this approach gave me the highest accuracy. But then you suddenly understood, like, okay, I do not need accuracy. I need precision or recall. How to get the data from accuracy, you cannot restore like those. So, and you do not have all the confusion metrics to find out what to calculate the precision and accuracy. So logging more data than you need is kind of helpful because you can come back. And also, like if you had a model, you were training, the results were increasing, and suddenly it decreased. If you do not have the history, you do not know which model was better before, like which experiment conditions were better. So logging is annoying, but it gives you all the results which are needed, and later you could come back to it without repetition of the experiment and just get the information what it's needed. Yes, with the summary of this part, like choose more than one data collection technique if it's possible. And there is no best method, like it depends on your situation, and usually like it depends on the availability of resources, of data, and so on. And the recommendation would be you shouldn't be adapting to the method. Like you should be adapting to the problem. And also it's like similar what we had in the beginning with Martina's, like if I have this technology, so I will try to investigate everything about this technology. So it's just like question of perspective, but at least like how you will present. If it's a problem is, yeah, like to estimate how this method is it powerful or no. So it's a clear problem, like I need to do. But if you are just playing, in the end, potentially in the PhD thesis defense, you will get a question like, why you needed it, why it's important, to estimate like which chair is more comfortable. So I have both of them, so I can choose on the way, and so on and so on. So this is why in the beginning, try to find what's the problem, what's the impact which you are trying to achieve. It helps to build in your head the image, what it's needed for, like the result importance and so on, and how to defend it. Yeah, now how to collect the data for the analysis. So in this case, when we are talking more about social science, when we have a huge population. So population will be, okay, it's not here, but basically if I need to gather the opinion of all Lithuanian citizens, so all the population is all Lithuanian citizens, which is about 2.5 million of people. So I cannot ask all of them. So I should have a smaller portion of it and just ask the data, the answers to them and get the result. So this is why like sampling is how we are selecting those smaller instances, groups in the population, because we need to make sure the population is representative, like we have enough of them, we have like they are matching the distribution of the population and so on. And one example which I kind of liked, for example, if I need to estimate what is the average household size of person, so how I should be, because I do not have access to all the statistical data, I will use some kind of approach. I found the persons and I'm asking in some system and it's expensive. So I just decided I will question, for example, 1,000 citizens and will get the data about what's the size of the household. So how to select what will be those 1,000? Will it be okay if I will select from each city or the same amount? The same amount from Vilnius, the same amount from Klaipėda, Šiauliai, Panevėžys, or even some small village. Can I do like this? Probably no, because probably some cities are more dense and they are living in multi-flat buildings. And if it's a smaller village, probably they are having personal houses and automatically the household is bigger. So then how I should be selecting? If I will select randomly in the map, those locations, also like it's the same problem. Some areas are more dense and so on. Then I could do just simply, I have a list, for example, used to there was such a thing like telephone book. Now I'm not sure, does it exist? So each person would be listed and I would select randomly some of them. So yeah, it increases. So how to select what is the suitable sample set? It's kind of a tricky, and also it depends on the context, what we are trying to do. And yeah, like there are some concepts which I forgot to show here. So like the population is the total set. So if it's Lithuanian citizens' opinion, so it's all Lithuanians. If it's, I don't know, students of Vilnius Tech, so it's all students of Vilnius Tech, if it's alumni and so on. So this is why like we should know what is the total population to estimate what is the suitable sample size. Then consensus usually, not consensus, but census is like collection of data from entire population. So yeah, if I'm able to do it, it would be nice, but usually like we are limited sample, so it will be some subset from the population. But also, as I mentioned, it would be nice to have balanced and well-distributed representative. And sample frame will be some kind of list from which we are selecting the sample. So as I mentioned, like in my example, it would be, for example, the phone book where all the Lithuanian citizens are provided which have phones and so on. So then there is sample design, so method of the sampling, how we will be picking parameters based on what we are selecting. So for example, is it city? Is it geographical distribution? Is it the fact that users should have a phone and so on? And statistics, like it will be some kind of a characteristics of the sample, like what are the distribution and so on. So random sampling is the most simple one. I'm just randomly selecting something from the sample list. So it could be applied, but also in the random sampling, even different approaches could be used. So simple, random interval, random start, fixed, and so on. So maybe also just quickly about each of those. So this one is completely like I'm just randomly selecting, but it's important to have the random number generator just to make sure it's real number, random, not just I prefer this one, so I will select and so on. Interval sample, so you will define from which interval you want, like, or you will define, like, I'm starting from this first one, and then I will select every 5 records. So the first one, the sixth one, the 11th one, and so on and so on. If random start and fixed interval, so also I will select not necessarily the first one, but somewhere from randomly, and then we'll go to some kind of a step. So stratified random sample, those who are familiar with machine learning probably knows what means stratified. So if I want to select randomly, but I know some kind of a categories. For example, I know, is it a city? Is it a village? So, and I know what is the proportion between those two in Lithuania. So I should be selecting appropriate proportion of those from the sample list as well. Or for example, if I know statistically there should be 50% of men, 50% of women. So also when I'm selecting the samples, I should be also trying to make sure both of those categories have the same distribution. Be careful. And sometimes it's kind of a tricky. We have not just one characteristic, we have multiple ones. For example, is it city or village? Is it man or women? Is it old, young, middle age? So it could be like a combination of all of them, and then trying to estimate appropriate sample size for each of them. So it just tries to then illustrate the more realistic distribution of features in the real data. So yeah, basically this one tries to estimate like, yeah, if I have half of those, so in my sample also I should have half of those as well, not just one from those and 99% from those. Meanwhile, this one is the majority. With the cluster, also what you can do, you can cluster the data and then from each of those clusters to select if you do not have specifically defined features who defines how it should be selected. Multi-stage random also, you could do like it in multi-stages based on your approach or using different approaches to get and then combining it together. Yeah, with this one, so those approaches, because it's random based, not necessarily will yield to accurate presentation of the population, because like we are just selecting randomly. So one of the approaches, like the non-random, it's sometimes feasible, but like also complicated, because you should clearly justify like, yeah, I'm selecting not randomly, but like there are no biases behind my selection. For example, if there is in the classroom multiple students and I'm selecting only those who are active to express their opinion. So why? Maybe those who are passive will have a completely different opinion and so on. Yeah, but sometimes it exists, especially if the population is very complicated. I cannot select. So sometimes, for example, even an expert could be selected to represent because he has opinion and can represent a bigger population opinion. So with those, so one type of non-random could be purposeful. So judgment snowball is reflected also when we have experts, but a limited number of experts. So I'm starting with several of them, and then I'm asking like, okay, I need more experts. Do you know some of them? Because they were experts in the field, maybe they know another expert. So it's like just from one going to another, to the third one, to the fourth one, and so on. So it's sometimes also risky because like maybe they have the same opinion and they are not presenting you experts which have completely different opinion. But it happens, as I mentioned, if you cannot have direct access, and usually if you have some expert-based evaluation. And convenience, it's just like it was more convenient for me to ask Vilnius Tech students rather than all Lithuanian universities in Klaipėda, in Marijampolė, or something like this. So this is why I selected those, and they should represent more or less the same. Yes, so there will be some examples as well about those type of non-random sampling, and shortcomings I discussed a little bit. And also, like, you could combine multiple of them, just like I selected something from here, and I'm just joining into a bigger sample size. And how to determine what should be the sample size? You should know it from master studies. And to be honest, like, it's probably my issue, but I do not try to remember all the formulas. Yeah, there is a formula which you could apply. Do I really need to know all the formulas, how it's calculated? No, because in most of the cases, you will find some calculators or some methods in statistical tools and so on and so on. So the more important for you is just to know what should be taken into account. So for example, when you are selecting the sample size, you should define what is the confidence interval. So and what is their error, like, so automatically I will need to provide the population size, my confidence intervals, and automatically it will calculate what should be the sample size, just to make sure with 95% confidence interval, to get the results, you should be asking this amount of persons. Yeah, and just a summary of the sampling, like, yeah, each of them have limitations, advantages, disadvantages, and also, like, it depends based on the situation you are selecting which one is better for you. So you are the expert. And what to do with data before the analysis, the pre-processing part. So yeah, in most of the cases, before you will analyze, you will need to do some initial data descriptive analysis. This approach just says, like, yeah, in most of the cases, you will collect the data quickly, the initial one, but to get more data, you will need more and more additional time. So it's tricky with so how I'm getting the data. So I'm usually in the beginning, like, do just a small data analysis with the initial data. Then I'm collecting more data through the time, but the proportion of analysis increasing. Like, I do not dedicate the same amount of time for the data collection. I'm more concentrating on the data analysis, and then until I will reach the point when, like, it's okay, it's enough to have the data which I have. And also, just one important comment regarding your PhD thesis. If you will try to make it perfect, you will never defend your PhD thesis, because always there will be something better, something new, what is not tested, more data to collect, and so on and so on. So in most of the cases, you need to have the threshold value, like, okay, this is enough. Like, now I will publish, I will defend, and then after the PhD thesis, I will continue doing research on this topic. So it's tricky to estimate when it's enough. Usually it's based on how many publications you have and what the supervisor tells, because they know what are the requirements in the field. Yeah, so with the qualitative analysis, you should be thinking, like, is there any difficulties? Okay, now I'm thinking what I needed to tell with the slides. Yeah, so basically it's just like recommendation, what you could ask in this type of an analysis, estimating, like, is my data already suitable for the further analysis, like the initial one, like, yeah. And okay, the issue is I don't remember those slides. It's from the last year, but Yeah, so more or less everything was here. Like you could go through those questions, but as I mentioned, it also will depend on the data. And the most important thing, if we are here, like in the beginning, why we do the initial analysis, just to see, are we able to do some kind of insights from the data? Can I estimate some correlation? Are there some patterns visible and so on? The further when we go, we are concentrating on different approach, like is the data enough to make sure I can estimate, is it statistically significant difference, or maybe it's not enough to summarize based on one of those features. If I had just couple of records which had this feature and those records are a little bit different than others, so can I trust just with two? Like, no, I should be getting more data and doing also the deeper analysis, what's happening and so on. Um, yeah, and with the collection of those, like uh, you should be, when you're collecting all the data, also trying to log by collecting such a things like ideas, impressions, and later you could be coming back, because especially feelings, they are fading through the period. So if you were analyzing, like monitoring, observing some situation, and if you didn't log all the situation, you might forget what was happening and you won't be able to come back to those. So this is why even when we do some observation, usually there are some protocols, like some sheets, which I'm using to fill information and log all it. Also with quantitative, it would be nice to meet frequently with the team to get some kind of a feedback. Yeah, and use quotations if you had some sources and so on, so on. Yeah, with the quantitative data, like also when you have data, in most of the cases, you should be using the statistics to estimate is it suitable or no, and also to analyze, can you provide some insights from it, draw some conclusions, estimate is it statistical significant and so on. Yeah, so drawing some themes or patterns, like is it showing something? And also it's kind of a tricky, like when you select the data, one of how you decide what kind of a chart to show in the data. I collected student feedback about overall satisfaction about one thing another, the third one about the demographic data and so on and so on. So one approach is, if you are good on the area, you know what's important for you. For example, if my problem was to estimate how the study quality depends on the course, so automatically I will be drawing a chart to estimate like how, depending on the course quality by students' feedback is estimated. But if I do not know if there are multiple features, the simpler approach is you are analyzing different perspectives, different charts, and then you estimate, like, can I see any pattern? Is it the same? So if it's the same and it do not depend on the factor, so it means probably it's not affecting it. If it's increasing, so yeah, probably there is something, but I could go deeper in to analyze why it's increasing or decreasing and so on. So this is why it says, like, try to draw some themes or patterns, like try to analyze and see what's behind the data, not just what's the average and so on. And also take into account what's the content. So one of examples, there was one PhD thesis and they were estimating how oil will be penetrated in the soil. And the experiments showed results. Like if I will take, I don't know, now it's just random numbers, 100 of oil, I will spill it, and minus 50 will be penetrated. What means minus 50? It evaporated, but I had 100, now I have minus 50. So it's not only those 100, none was used, go into the soil. It means even from the soil, someone extracted half of it. And the answer was like, what does it mean? And the answer from the student was, we didn't analyze. It shouldn't be like this. If in this case, because it was just a modeling, you could use a very simple approach. You could do like, okay, I'm modeling, there is some kind of a pattern, but I'm adding just limitations, like it should be zero. If I get less than zero, it's still zero. So adding such a conditions gives you adds some kind of a context to the situation. There is no such a thing like it evaporated from the ground without using any additional equipment and so on. So if you will take into account what the context means, the same as with the like there were no attacks against our system, like no, like probably you just do not understand what kind of a measures should be faced in, and number of attacks do not define how secure the system is. It just define how popular you are among attackers. Let's assume like this. So this is why you should be adding the content to your analysis. And yeah, if you have numbers, it's very easy to do the analysis by using some tools because it could allow you to do all the statistical analysis, to visualize the data and so on. So don't be scared to use those tools and to use different visualizations and so on. Yeah, now I'm just like, yeah, so what you will need for here, so several highlighters, so you can use, because if we have just text or I don't know, some interviews, so just using some highlights could help to estimate what are the main keywords. And even with qualitative data, for example, if I have some opinion, you could try to incorporate some quantitative data as well, especially when we have those AI tools. For example, I could estimate what is the sentiment by just using some AI tool, or what are the keywords, like the main important things, and based on those keywords, try to estimate what is the similarity between different experts or something like this. Yeah, so with those, it's up to you. Like, it's just some recommendations what you could use to highlight, to include some additional data even in those qualitative. And also another thing is you could use some coding. So for example, as I mentioned, like if there was some text, you could define how you will estimate and will code into numbers, like the same, like what is the sentiment, or what the topic the student was expressing, or some kind of a, so coding would be just based on deeper data, like more bigger data, to estimate the essence and assign label, and multiple labels could be added to the specific case just to make sure then you have categories, and based on categories you can use some quantitative analysis. Yeah, so if you will have categories, you will be able to use the same mathematical approaches, because usually those categories will be converted into numbers. And also there is one tricky situation. For example, when you have categories and when you are labeling, so with the labeling, usually we assign numbers. So if I had, I don't know, there were labels cat, dog, and bird. Who should be one, who should be two, who should be three? Probably doesn't matter. But then computer will be analyzing 1 and 2 and 1 and 3, there are different distances. So if it's feasible to estimate, you could order them. For example, maybe I will order based on the average size. So the bird is the smaller one, it should be 1, then there should be cats, then should be dogs, something like this. So it's not accurate, but at least some kind of a pattern is visible. So when I have, for example, week of the day, Monday, Tuesday, and so on, so also it will look strange if Monday will be 2, Wednesday will be, Thursday will be 7 or something like this. So if it's feasible, just try to order them and use those codings in numbers in this order, because then the difference between cat and dog, cat and bird will be more visible, rather than, okay, it's not this one, and so on. Yeah, and with the triangularity I mentioned already, so if it's possible, try to use different approaches, just to use different methods or different data as it was previously, just to make sure you have multiple perspectives, let's call it like this, to support the same evidence. Yeah, like even on the qualitative data, you could do some calculations if you will be converting it into categories, and automatically categories into numbers will be converted automatically. And the statistics also, like you could use a descriptive statistics, like just frequencies, how many of your respondents were like positive, negative, or some kind of like this. About this one I mentioned already. Also, another question is about cleaning data. So what is cleaning data? When you have data, usually there are some challenges with it. Not all data is full data. So there are one approach. Okay, I could delete all missing data. For example, I got just the final feedback. I do not have anything about the um, geographical distribution or something like this. But this approach is sometimes feasible, but sometimes if you will, because one example from bachelor studies, student had a data set with 5 classes. He did a classificator and he saw like the 5th class is very complicated. It's not accurate and it decreases the course. So what he did, he deleted the class. And then he created a classification for 4 classes. The accuracy was higher. So does it mean the result is achieved? The problem was I have possible 5 inputs, so my classifier should work with 5 inputs. So I cannot delete data which is not suitable for me. I should justify why I'm deleting one data or another. For example, if it's missing data, like I do not have the label, so I do not know how to label it. If I do not know, I should be removing it as not appropriate, or if there are some errors, very visible errors like outliers, I getting the evaluation from 0 to 10, it should be, and I'm getting 100. So no, it's not reliable. So cleaning should be like you are removing some data, you are balancing the data as well. If you have too much, I don't know, girl's opinion and you want to be, so you could remove some, but also not just, I do not like this one, I prefer this one. You should do it more accurate, like with justification. Yeah, and those will be more about descriptive statistics, because what's here, like we have those 3 M's, like mode, median, and mean. So you shouldn't be concentrating only on mean, average, because I had some kind of an image somewhere. Okay, we will come back to it. So because mean do not present the overall, as I mentioned, like 2, 10, average is 6, so it's not what we need. So this is why, like, usually you use this one. My recommendation usually is like not just mode, median, you should be using standard deviation, variation, as many metrics as possible to illustrate the data distribution more accurately. Yeah, so with a nominal data, I assume you know those, like what's the difference between nominal, ordinal, and because I have 150 slides, so I'm concerned like I should be going quickly through some of those. So you will find those. And yes, there was an example, like, for example, I have country, I have urban. If I will calculate just the mode, median, mean, so it should be calculated like this. And the variation when I'm counting, so for example, if you will be calculating just average, I have 3 situations. In one, the first one, second, and third one, all of them will have the same average, the same mean, 3. But the result distribution is completely different. So this is why at least provides a range, but even with the range, it will be complicated, because this one, the range will be 0, but for those 2, it will be 4, because it just says minimum, maximum. So this is why more or less the standard metric is the standard deviation, which defines like how your data is distributed. And just quickly, like which of those is the best one? What you are trying to achieve. If you created a new, I don't know, device which measures the temperature, so you want your results to be distributed like this, like this, like this, or like this. Yeah, because it should be as close to the real value as possible. And I do not want a high deviation like distribution. If I have this one and this one, which one is better? Because the deviation probably is similar, just the location is different. So if it's similar, it's better to have closer to the center, because this one, maybe it's even like more not so diverse, but it do not represent accurately. I have the center somewhere here. But if you have a calibration possibility, this one would be better because the skewness is smaller. But at the same time, I could shift and say like, okay, if the temperature was 100, but my thermometer is showing 80, so all the time I will be minusing 20 and I will get the result. And this one usually is a worse situation because the average is more or less the same, but I get results sometimes 120, sometimes 80, so I cannot trust the data. So yeah, like it's relevant to machine learning, but also to your experiments as well. And also, do not be afraid of some statistical visualizations like quartiles, because those allows reader quickly to understand how your population, how your sample is distributed. Like in this case, I see like, okay, it's evenly distributed. In this case, I see like, yeah, in this interval, I have the same amount as in this interval. So it means like those were more close, like I had bigger number of the same results. So it just illustrates. And what the dot means? Outlier. So outlier is something like, oh, it do not match to this distribution. Either it's error or it's completely different like approach and we shouldn't be taking into account. So with the standard deviation, so basically it solves the question with the range and with the mean. So if you will provide it, it will allow us to understand where how your data is distributed, how it varies. So for example, the formula is like this, but I do not remember it. I just use some formulas, even Excel has those. How it's calculated, the idea is like we have the normal distribution, how this one was generated. If all events have the same probability, so if I roll the dice once, the distribution will be this kind. If I will roll twice, it will be like this one. So it means like the more times I'm measuring, the more close to the bell form it should be. So why we need the standard deviation, it also simply allows us to understand what is the range of possible results. So if I have a standard deviation, one standard deviation, and this is the mean value, so -1 + 1, I will know like, okay, 68% of my results will be in this interval. -1 + 1. And usually we are using -2 + 2 because then we will cover about 95%. So this like 95% of our results will be distributed in this interval. So if in my case, I have average of student satisfaction 7 and the standard deviation is 0.5. So what are the results? What is the interval? 7 and 0.5. I will multiply by 2, so 1. So 7 + 1 plus -1. So in 95% of cases, the results will be either 6, either 7, or 8. So, yeah, so if the average, okay, let's calculate like this, not with a student. If I will calculate the average age in this audience, and let's assume it will be, I don't know, 30. With just average, I do not know anything. I do not understand how old is the oldest one, how young is the youngest one. And if I know the standard deviation is, let's say, 5. So with 95% like probability, what will be the oldest person if the average is 30? With 95, not with 68. Plus 2 standard deviations. So if it's 5 multiplied by 2, 10. So 30 minus 10 is 20. 30 plus 10 is 40. So then it means 95% of you is in this range, from 20 to 40. If the standard deviation is 10, so it will be from 10 to 50. And it's also tricky, like why I was saying like you should be taking into account the context. Is it possible we will have a PhD student whose age is 10? It's statistics. It says like, yeah, 95% will be in this range. So also you should be taking even such a small things like, yeah, it shows like it's this range, But in practice, like our smallest value is from, I don't know, probably about 28, something like this. I don't remember now, something like this. So you should be taking into account what the data means when you are analyzing and presenting the results. There shouldn't be like the youngest defended student was 10 years old. No, at least not in Lithuania. And also like use different statistics like correlation. Like correlation says, is there any dependency between two variables? But what's tricky with correlation, usually it just reflects linear dependency. If I'm increasing this one and this one increases and there is no deviation, so we will have the correlation 1. If I'm increasing one and another is decreasing, very clearly we will get -1. So the correlation usually is from -1 to 1. If I got 0, so it means like it's just random. There is no dependency between those. So usually in statistics, 0.3, 0.4 is already calculated as there is a relationship between those, like with some nuances, but it exists. Yes, like recommendation like 0.5 would be like moderate or 0.2 like slight weak, but yeah, it depends on the content as well. Yeah, so using statistics is kind of a powerful because sometimes it allows you to justify your result. For example, there are some tests which you could use, but also do not try to remember how it's calculated. There are some tools which you can use. It's just one of those. If I will say something, okay, I had a model and machine learning model, and its accuracy was 95%. So 95 cases were classified correctly. And I created another model, and now its accuracy is 96. Is it better or no? Mm-hmm. But if the accuracy is 1%, and I was testing just with, I don't know, to get 95, 96, so let's assume is 100 cases. So there is a chance it's just statistical error. And it's not significant. So it's just also statistics because I liked one student's answer when I was asking, like, is it statistically significant? Based on those calculations, it wasn't because like it was 99.99 and he achieved 99.99, like 4 nines, not just three. So, but he was saying, but I'm classifying medical data and each patient's life is very important. So yeah, like in practice, even those small numbers after the dot is important to us, but also Antanas probably mentioned, when you are presenting results, do not add multiple numbers after the dot. Maximum is 2. Because what does it mean if I classified and like, if I'm asking, what time is it? Probably you will tell in minutes, but not in seconds, not in milliseconds or nanoseconds. So it's the same with all your metrics, like taking into account what is the error and how accurate you should be presenting. But coming back to those, so if you did some kind of a testing, so those, is it statistical significant or no? You can use, for example, the t-test. You will provide how many samples you had, what is the average of one sample, what is the standard deviation of one sample, what's the average of another, what's the standard deviation, and taking into account how diverse the data are, what are the average, you will get the metric by saying like, yeah, like if it's less than 0.05, so based on it, you can estimate is it statistically significant or not. So as I mentioned, like if my average is 30, and if I know the standard deviation is 10, and another experiment told like, okay, the average is 31 and my standard deviation is 9. It's still the same. Like we still are in the same bell. There is no differences. But if I have like, at least in my health, is those normal distributions. So if they are not so much intersecting, so it means like, yeah, those two sets are different. So we can say like, yeah, it's statistical significant. Yeah, so I'm just like saying like it's just statistics, but it's additional tool to convince like, yeah, I did some analysis and I know this one number after the dot is significant. It's not just like, yeah, it's fifth number after the dot. I still believe it's better than the existing one, but it might be related to the fact how you calculated and so on. Yeah, so ideally it would be nice if you would join those two approaches, because with numbers you would get one data, with qualitative data you would get a deeper insight. So basically, for example, it says like, yeah, one is answering how, another is why. But yeah, it's just, if it's possible, use a triangulation approach, trying different methods, different data, and so on, just to have more realistic data. And this one is completely what you already know, because just like, always remember, when you will be writing article or PhD thesis, someone will need to read. And the someone usually is like, yeah, expert in the field, but he or she doesn't have huge amount of time to read. He or she do not know everything what you do. So this is why you need to present all the needed information, and at the same time to present it in reader friendly format. So try to use some visualizations, tables, charts, but using those, you should be at the same time making sure it's representative and provides all the information. So yeah, like it just says, like it could be some illustrations, charts, and so on. So with charts, what are the must have? You need to label what's in the X and what's in the U chart axis. Otherwise, like it's just numbers and I'm not sure what's happening. Another big problem is when you should be using liner chart and one bar chart. Just several minutes. Okay. So if you have continuous value like date, so it's all good with this one. But if I have Monday, Tuesday, Wednesday, can I use line charts? Between one and another, like if it's 1, 2, 5, just imagine if it x-axis is just numbers, what means 1.5? Is it Monday or Tuesday? No one knows. So if you cannot divide into smaller chunks, like if it's time, so yeah, day, minute, hour, I could show, because the idea is if I have this dot and this dot, if I have line, so it means everything on this line is correct. So if it's end of March, beginning, end of February, beginning of March, so it means the value will be here. If it's in the middle of March, I'm assuming it's here or something like this. So if it's categorical data, do not use lines, use bars. Yeah, it's about how it should be presented. You can add the error bars, like more for histograms or just categorical. For example, yeah, like question number. What means 1.5? I cannot add line here. With pie charts, you should be like just showing distribution between scatter plot allows to estimate how it's divided, which one to use when there are some, with tables, do not write too much text in those tables. Like tables are dedicated just to present the values. So if it will be a huge amount of text in each of those columns, like I should be reading it, so it's not very convenient. Yeah, and in the end, there will be some questions just for you, like we don't have time. So just use those as self-evaluation questions. Would you know what to answer? So for example, what are the main issues here? Like based on the diagram, what I could tell. Or for example, what's good or bad with those charts? For each of this case, just evaluate relevance, credibility, validity, and reliability of the data, like could I use it or no. So as I mentioned, it's more for you. Yeah, and most important for you will be with everything, with data, methods, and so on. Like there are some limitations, just you need to bring it and to list it. So it's not necessary. And also just what Antanas used to tell to me, because he was my supervisor, the absence of results is also a result. What does it mean? In the beginning, I was, come on, like if I was creating a machine learning method and it's not suitable, it's just like two classes and the probability is 50%. So it's nothing I didn't achieve. And he was saying like, no, you got new knowledge. You found it out this method is not suitable for this task. So it's also just how you will convert it. If your purpose was not to find the best model, but to estimate, is this method suitable for this task? So it's something similar. So then it's still a result. You got new knowledge. So if you have any questions, because we do not have time, so do not hesitate and you can email me. My email is the same as all professors, like name.surname@vilniustech.lt. And I will try to send those slides and the video of the lecture by email to you. Not necessary today, but I will try to do it this week. You will have a